This is question number 6 of practice homework 4, problem 8-6. The firm is contemplating the purchase of a new $630,000 computer-based order entry system. The system will be depreciated straight line to zero over its 5-year line. So this is the initial investment. It will be worth $70,000 at the end of that time. So this is the terminal value. You will save $260,000 before taxes per year in order processing costs, and you will be able to reduce working capital by this. So this is a one-time reduction. So that means this will, the working capital will be reduced at time zero, and the level will be, the lower level will be maintained. But remember, when we talk about the capital budgeting, we said in general, when the project is completed, the working capital will be returned. So that also applies here. So that suggests this one-time reduction at time zero, in terms of cash flow, that's a positive one, and that cash flow will be retained by the end of the project. So by year, I guess this is a five-year project. So by year 5, this level of the net working capital will be returned. Hence, there will be a negative cash flow by the end of the project because of this returning of net working capital to its original level. So if the tax rate is 30%, what is the IRR? So we want to use Excel to solve this problem. To set up the Excel, we have this year 0, year 1, year 2, year 3, year 4, year 5. So we have 5 years. And the initial cost, so this is the initial investment. So this is the initial investment. That's the 630,000. And we also have the terminal value is $70,000. So that's the terminal or the salvage value. Salvage value by the end of the 5th year will be $70,000. But remember, this is the before tax salvage value, and the taxes will be levied on the difference between this number and the remaining book value of the asset. And we are also told about the depreciation, which is straight line depreciation to zero over its 5 year. So every year the depreciation will be, so that's gonna be this amount. Let me call this dollar sign, use the dollar sign to fix that. So later on we can just pull the cells. So this is every year the depreciation will be this much. So by the end of the project, so let me move this line here just to, so taxes on salvage will be, because the remaining book value by the end of the project will be zero, right? That's the assumption here. So the taxes will be based on this salvage value, will just be based on this salvage value. So that's gonna be the tax rate. Tax rate is 30%. 30% times this salvage value. Hence, after tax salvage value will be this salvage minus that. So that's the after tax salvage value. And now we also we're also told about you can save this much before taxes. So let's put this like this is like uh, the cash flow, the positive cash flow savings. So this serves as a positive cash flow. So that's gonna be the same every year. We just put the sale here. Every year it's the same, $260,000. And you will be able to reduce, this is the reduction of working capital. But for these two, we can actually calculate the operating cash flow. The operating cash flow. The operating cash flow is simply, why don't we first calculate the EBIT. EBIT will be the savings minus the depreciation, right? That's the EBIT. And as we said, for capital budgeting, we generally assume that when we calculate the cash flows, we assume that there's no debt. So EBIT is also EBT, and now that also means we can calculate the taxes based on this. Taxes will be the 30% times this EBIT. So every year it's going to be the same, and net income will be net income. Remember, all these are incremental to this project only. So all we're talking about here is the incremental to this project, and that's what matters, the incremental cash flows. So it's EBIT minus these taxes. That's my net income. And eventually we want to calculate this operating cash flow. Operating cash flow is simply EBIT plus depreciation and minus taxes, right? So if we don't have any interest payment, the operating cash flow could also be written as simply the net income plus the depreciation. So that's simply it's the same. So that's the operating cash flow, and now with that we can the change in net working capital. So here it's $85,000. So remember, we need to deduct this change. So this will eventually become a negative cash flow for year 0. And as we said, when the project is completed, all the incremental net working capital will be reduced, will be returned. It will be returned. Hence, eventually we'll have a negative $85,000 change in net working capital here. I think I probably messed up the sign. Here should be negative because it reduces the cash flow, so it's gonna be a negative number. But eventually we're gonna minus this negative number, hence it will add up a positive number. But here it's we'll go back to the higher original level of the net working capital, hence this will become a positive change for the net working capital. But in terms of cash flow, because eventually we reduce, we minus this amount, the change in net working capital, so this will become a negative cash flow. So now the free cash flow, is simply the it's the operating cash flow minus the initial investment, and then minus this after tax salvage value, or plus, should be plus after tax salvage value, and minus this change in net working capital. So now let's pull this all the way to the last year. And this is the free cash flow. Now, knowing this free cash flow, we can further calculate the IRR. using the equation, the function Excel. In Excel, the function is simply also called IRR. And open parentheses, you can see there are basically two arguments here. First one is the values. So this values means the cash flows, starting from year zero's cash flow. And the second argument here is a guess. So guess is the initial guess value for IRR, because IRR also use sort of a trial and error until the NPV converges to zero, because the definition of IRR is the discount rate that makes NPV to be zero. So this guess is where we start for the discount rate, which we want to calculate the NPV until the NPV converges to zero. But in this case, we don't require this guess, because based on the cash flow pattern, you can see that it started from negative cash flow and goes to positive cash flow. So this type of cash flow pattern can only have one IRR. So no matter what your initial gas value is, it will converge to that unique single final IRR. So let's just put the cash flows in and then close that. So we need to make sure we conform with the rounding requirement. Do not round the intermediate calculations. Enter your answer as a percent rounded to two decimal places. So we want to, this is percent already, but we need to make sure we round it to two decimal places. And now you see once we change the format, this will be different, slightly different. So now let's put back and check our answer. Good job.